Section 8.8, business and economic applications. And break-even analysis. The money that the business spends to manufacture a product is the cost. The total cost of production can be thought as a function of C. Cx is the cost of producing X unit. When a company sells its product, it takes the money. This is revenue and can be thought as a function of R. So the formula is this: profit is revenue minus cost. So equation is equation of the profit is equal to equation of revenue minus equation of the cost. So do not confuse cost with the price. When we discuss the cost of the item, we are referring to what it costs to produce the item. The price of item is what consumer pays to purchase the item and is used when calculating revenue. Now, like in this example, Renewable Design is planning to make a new chair. Fixed cost will be $90,000 and it will cost $150 to produce each chair. So cost of producing each chair is $150 and you sell it for $400. You see, you go from $150 to $400. And there is always a fixed cost. Fixed cost is because the manufacturer has to pay for the rent and utility and workers' wages, stuff like that. So when we ask you to find the total cost is always the fixed cost plus the variable cost. Variable cost is it costs one chair $150, depend how many chairs you're producing. So you have to multiply that by 150. 150 is the cost of one chair plus the fixed cost. When you sell number of chairs for 400 each, the 400x is your revenue. So how do I find the profit? Profit is revenue minus the cost. So you remember when you put in the formula, you must always put a parenthesis before you actually multiply the negative sign. So when you multiply the negative sign, then negative would impact the 150x. So you have 400x minus 150x, that would give you 250x minus 90,000. So this is the profit equations. Then you feel that, hey, the profit equation has X in it. And what if this X, what if we sell 300? If we sell 300, we are going to lose money. It's in the negative 15,000. What if I sell 800 chairs? Then you gain, you make money. See, it's a positive 110,000. Okay. So this is your equation of the cost. This is equation of the revenue, and this is equation of the profit. And when you are graphing these two CX and RX, then there is a point, they call it break-even point. And break-even point is the place that cost and revenue are the same. You neither lose money nor gain. We also have supply and demand. Well, let's just work on some of the break-even point first, and then we get to supply and demand. Here, suppose that certain company, the CX is given and RX is given. See, CX and RX, cost and revenue are given. They want you to find the profit. The profit is revenue minus the cost, RX minus CX. You want to make sure you put a parenthesis before you actually multiply this -1 by that. So this is your equation of the profit. The profit equation is this. And then they ask you to find a break-even point. Remember, break-even point is where cost and revenue both are the same. Altogether, it costs $800 and you sell for $800. Okay, so you're not gaining or losing any money. So in that case, when we ask you to find a break-even point, you're just taking equation of the Rx and Cx and equal to each other. I would put that Rx first because 65, normally 65x is greater than 25x. So in that case, when you move 25x to this side, the outcome would be positive. So that gives you the value of x, means if you sell 7,500, then what's the y value? To find a y value, you could use one of these two equations. You could, when you find the x, you could use one of these two equations. Both equations give you the same number, so it's easier to just use that one. So here, when I find a break-even point, which is 7,500, I'll multiply by 65. But to show you that in either case you have the same number, I also put that number on the second equation. See, in either case, you have that number for 487,500. So it's better to use this one. So remember, break-even point is when Rx and Cx are equal. What's the profit? Revenue minus cost. Second problems and the third problems, they all are very, very similar. And I think the fourth one, look. See, problem number 2 is very similar. So this is your x, this is your y. Problem number 3 also. First, he asks you to find the profit, then the break-even point. What is the break-even point when these are equal? All right, so then next subject is, we call it supply and demand. Let's go get back to that one. Supply and demand, they have an example here. There are two types of graph for supply and demand. Like in this one, as the price of the coffee varies, so too does the amount sold. The table and graph below show the consumer will demand less as the price goes up. So in this example, price of the coffee is more expensive. So let's say the first month the first year they start with $1,600, $16, and then they raise it next year to 18 or 20. So as the price goes up, demand reduce. People buy less. So this is the supply graph. And the other one is the first one is demand, because demand reduce. Second one is the supply functions, okay? As the price of the coffee varies, the amount made available varies as well. The table and the graph below show the seller will supply more as the price goes up. This is in the case that in the market, the price of one item is going up, but there is always a good demand for it. One good example is the housing prices. When the people are asking for more homes, then the price goes up. So this is the supply. If the manufacturer feel there is a market for a particular item, they try to produce more and get a higher price because people would buy it regardless. Now, these two, supply and demand, is like break-even point. They intersect at the point. They call this point equilibrium point. Equilibrium point is like a break-even point. The differences here is when the supply and demand are equal. So let's say you have the equation of the demand, you have equation of the supply. When you set these two equal to each other, then you find the break-even point. And this is the example that you have. See, the equation of each is given. You set it equal to each other. Now, this is problem number 4. And then problem number 5 is indication of that supply and demand, they ask us to find equilibrium point. Equilibrium point is when, we don't really need this one. When demand and supply are equal. When demand and supply are equal, then you set this to equal, you find the value, the price. When you find it, again, you put it in one of these two equations, like here, I put it in this equations to find the other ones. So this is equilibrium point 70 and 1600. Second example, the supply and demand equation are given. You set these two equal to each other. You find the value of P and you put it on the other one to find the other value, like X and Y.